I'm fine. Sorry for the delay.
No problem. We were just waiting for you.
Yeah.
So we will start with the program for today. Nasir,
Yes.
sir?
Yes, madam.
Uh, yes, sir, we are
With the
starting.
permission.
Okay. So on behalf of Department of, very good evening to everyone present. We also have our principal, Dr. K.S. Zakiuddin, sir, joining the session. We welcome you, sir. So on behalf of Department of Electronics and Telecommunication Engineering, Anjuman College of Engineering and Technology, I, Dr. Ruhina Kazi, Head of the Department Electronics and Telecommunication, welcome you all to the 4th day of Atal Online 6-day Faculty Development Program titled Harnessing AI Technologies for Sustainable Rural Agriculture from 17 to 22nd February 2025. So today we have the first session on cognitive radio wireless sensor networks for smart agriculture, and it will be delivered by Dr. Rajeshri Raut ma'am from Government Engineering, Nagpur. Dr. Rajeshri Raut, Associate Professor and Dean, III Cell and Placement, Government College of Engineering, Nagpur, is a graduate and a postgraduate from 2002 from Government College of Engineering, Amravati. She has done her PhD in error control coding in the year 2011. Recently, she is awarded with the Singapore International Educational Excellence Award 2024 by Global Research Conference Forum. She is elected unopposed in as RTMNU BOS member for electronics. She has 26 years of teaching experience and industrial experience of about 1.5 years. Her achievements include Outstanding Researcher Award by INSO, April 2023, Nagpur City Mayor Award as Women Achiever, March 2019, ISTE National Award for Innovative Research in Engineering 2017, ISTE National Award for Best Engineering Teacher 2013, RTMNU Nagpur University Best Teacher Award 2011, IIFS New Delhi Shikshan Ratna Award 2011. More than 120 research, she has done around more than 120 research publications with SCI, Scopus, Web of Science journals having more than 300 plus citations. She has also delivered expert talks and chaired international conferences abroad in countries like Japan, Mexico, Dubai, and Malaysia. She is the advisory and editorial board member for many international journals. 8 research scholars have been awarded PhD under her guidance. She is the only and the first lady to represent ISTE Maharashtra and Goa section. She is executive member of IETE Nagpur. She is a fellow of IEI and a fellow of IETE. She has authored around 2 books. The project guided by Dr. Raut, titled Design of PSP System in Cognitive Environment, was awarded Best Engineering College Project Award for the Maharashtra State in February 2016 by ISTE. Project title Cattle Health Monitoring Systems received a grant of 1 lakh and was awarded the best project of Vidarbha region and presented at IIT Delhi as top 100 projects from all over India. Other sponsored projects successfully executed by her include projects from Solar Industries, Emitech Electronics New Delhi, Inotech Antennas Private Limited. Then in association with IID, she is well-known personality for her work in cognitive radio communications and having an innumerous laurels to her profile. We welcome you, ma'am, and we now request you to kindly continue with your session.
Thank you, Ruhina ma'am, for such a nice introduction. A very good evening to respected principal sir and my friend also. And a very good evening to the faculties of ACET, the organizers, and to my dear participants. It's indeed an honor to address this elite group and take this opportunity to have a discussion with you. I'm saying discussion instead of an expert lecture because I have the same expectation that this will be an interactive session. It is concerning 3 technologies or 3 aspects. It is cognitive radio, it is sensor networks, and it is use of this cognitive radio sensor networks for agriculture. So we need to understand these 3 step by step. Agriculture, of course, all of you are familiar with. First of all, we'll try to understand what is cognitive radio networks. Then we'll go to the smart sensors being used for agriculture, and then we'll try to connect the 3. Fine. So I'm addressing a group of electronics and telecommunication as well as computer science. I understand, right? This is what I understand. Okay. So how many of you are familiar with this term, cognitive radio technology? I will see the chat. Any of you familiar with this cognitive radio technology? I of course know Ruhina ma'am is familiar. Others? Anyone else? It should be an interactive session, of course. Am I clearly audible to all of you?
Yes, ma'am. You're audible.
Yes, yes,
Yes, yes, madam.
yes. Yes, my friend Nasruddin sir is also there.
Sorry, what was the question?
Familiar with this technology? Not aware? Okay. Prabhakara sir is saying not aware. Fine. Okay. Fine. So let us not directly come to it. I'll just open. I will just share my PPT also.
What was the question, ma'am?
Are you aware about the cognitive radio technology?
Yes, ma'am. No, I am not aware.
Okay. Fine. You
thanks.
are aware. Okay. Okay. Anybody else is aware? Is anybody else aware? Traditional wireless sensor network. Okay, fine. Typically cognitive radio network. Manish sir, are you aware about the? Okay, fine. No. So okay, fine. No problem. So I begin with sharing my slide. My slides are visible.
Yes, madam.
Okay, fine. Yeah. So, see, cognitive radio technology and its application for smart agriculture. I have skipped that smart sensor networks. The reason is it is imbibed in smart agriculture. The sensor networks are imbibed in the smart agriculture world. Okay, fine. So basically, this is like what do you say? Just give me the definition of bandwidth. Yes, on the chat box. Definition of bandwidth. I mean, what is bandwidth? It's a range of frequencies, right? For wireless communication, right?
Yes,
Yeah.
yes, madam.
Yeah. And how many of you know it is limited? Do you agree with my saying that transmission bandwidth is limited?
Yes, ma'am.
Yes. Why? Because it has a lower limit and it has an upper limit. Can anybody tell me why it has a lower limit? Come on, it should be interactive. Why it has a lower limit? Yes, come on. Anybody, whatever comes to your mind. Why does a transmission bandwidth has a lower limit? Lower limit in the sense below a certain level of frequencies, we cannot transmit with using those low frequencies. Yes. Yeah, my friend Ganar sir is also there. Why we cannot transmit using low frequencies? The answer lies in the use of modulation. The basis of modulation. Well, let me tell you, E is equals to h nu. All of you know this equation, right? Energy associated with any signal is equal to the Planck's constant h into its frequency. Fine. So lower the frequency, lower is the energy associated with the signal. Okay. And if the energy associated with the signal is less, then definitely that signal will not be able to transmit to a longer distance. Why? Very simple. If I throw a ball and if a small child throws a ball, definitely I will throw it at a longer distance rather than the child throwing it. The reason is that it is, I definitely have higher power, higher energy. Okay, fine. Just a minute. So now, if this is the case, lower limit you have understood, right? That yes, I cannot E is equals to h nu tells us what is the lower limit. This is the basis for modulation. Now think of the higher limit. Why do I say that I should not use? We do have higher level frequencies or higher range frequencies, but you should not go for high frequencies for transmission. Can anybody tell me that? See, I'm saying that we do have it available, but then you shouldn't use it.
More power loss.
Why do I say that? अगर आपका काम 4G से हो रहा है तो you shouldn't unnecessarily go for 5G. If अगर 5G से हो रहा है, so you shouldn't unnecessarily go for 6G. That way also that question can be put. Due to side effects. Very correct, sir. Manish sir, very correct. Definitely there are human hazards to the beings, not only human beings but all living beings on the earth definitely face hazards due to the higher use of high frequencies in gigahertz. Let me tell you that 8.6 gigahertz is the frequency which is being used in the 5G communication, and this 8.6 gigahertz is actually the frequency at which a bullet is fired from a gun. Gunshot का जो frequency होता है is 8.6 gigahertz, and this it has the capacity to pierce your skin, right? मतलब आपको wound करके अंदर pierce होने capacity is there. Fine, it has that capacity. Now imagine if the same is, of course, because it has a mass, the wound, but then the waves, they do not have that much mass, so that wound will not be visible, but they will have the capacity to penetrate your skin, go into your body, right? So definitely anything being absorbed by the body is dangerous for the body. That is one. Yes, I beg your pardon, anybody wants to say something? Okay, fine. And in addition to this, just see the cost associated with high frequency, because high frequency is high power, high energy. Fine, okay, energy correlated. So the power associated with high frequency signal is high, and if power is high, definitely you will high power handling devices, and high power devices are all costly. May be a smallest of the component, the SL100, which is the power transistor. Then the BC14557 is a normal transistor. Compare a normal transistor with SL100. So price of SL100, then the heat sink and all required for that power circuits, fine. So just see, जैसे ही power devices आ जाते हैं, so what makes it complicated is the handling required and the cost that is incurred on the high power devices. May it be the smallest one. Then think of the RF generators. जो RF generators हम UHF lab में use करते हैं और जो normal frequency generators हम EDC lab में use करते हैं. Price difference है. एक का the EDC lab frequency generators are just 3,000 to 5,000, whereas the RF generators are ranging from 15,000 to 20,000. Think of the analysis devices, the CROs. The 25 megahertz CRO is costing 15 to 20,000, and the 100 megahertz CRO is costing to 50,000. So ये difference है. Analysis devices में भी ये difference है. So definitely the high power transmitters जो use होंगे, they will definitely cost very, very high as compared to the low power transmitters. And therefore I say that the bandwidth, the usable bandwidth, transmission bandwidth is limited. तो रास्ता जो है, wireless path जो है, वो limited है. ये मुझे आपको यहाँ पे समझाना था. अब अगर ये limited है, तो जो चीज limited है, whatever is limited, that has to be utilized fully. Do you agree, all of you? जो भी चीज लिमिटेड है वो तो फुली यूटिलाइज होनी चाहिए. बचपन में कभी ट्रंक में मम्मी ने आपके सारे काम की चीजें ट्रंक में गांव जाते समय भरी होगी. जब आप भरते थे तो कुछ ना कुछ वॉइड स्पेसेस वहां पे रखते थे. देन मम्मी यूज्ड टू कम एंड देन फिल द ट्रंक फॉर यू, द सूटकेस, द ट्रंक, व्हाटएवर यू कॉल्ड. पुराने जमाने में ट्रंक थी, अभी सूटकेस है, बट व्हेन योर मदर पैक्स इट फॉर यू, डेफिनेटली सारी चीजें उसमें आ जाती है. लेकिन जब हम पैकिंग करने की कोशिश करते थे बचपन में, तो वो पूरा नहीं आता था. व्हाई? बिकॉज शी डिड नॉट लीव वॉइड स्पेसेस. लेकिन वही वॉइड स्पेसेस आज वायरलेस पाथ पे है. द पाथ विच इज सो सो ओवरक्राउडेड, वहां पे वॉइड स्पेसेस है. ओवरक्राउडेड क्यों है? विच एप्लीकेशन मेक्स इट ओवरक्राउडेड? कैन एनीबडी टेल मी? Which application of the in the wireless communication makes the bandwidth overcrowded, overpopulated? Yes, are you getting it? जो मैं कहना चाह रही हूँ वो समझ में आ रहा है आपको? I have not started with the presentation yet. I am just building the foundation. Concept समझ जाने की कोशिश कर रही हूँ. आपको समझ में आ रहा है? Yes or no? I want an interactive yes by the ones who are actively listening. जो actively सुन रहे हैं yes type करिए please. Okay, fine. You are understanding. If you are understanding, yes. Otherwise, a no is also accepted. Okay, fine. Thank you so much. So that means that whatever is available in limited, we have to fully utilize it. We don't have to leave void spaces. Now think कि क्या usable spectrum में void spaces है या नहीं है? Definitely है. आप लोगों के यहाँ टेलीविजन है. टेलीविजन में कितने सारे चैनल्स है? There are so many channels in the television set. But are you tuning to all channels? Definitely not. Somebody has raised hand. Avinash Raut. Do you want to say something? Avinash Raut, sir, do you want to say something? Hand is raised. Raut, sir? Okay, fine. So it was by mistake. No problem. So, see, like when I'm talking of the void spaces of wireless communication band, it is very evident example is of your television receivers. आपके receivers में आस्था, God, ये सारे channels है. Do you log on to that channels? Definitely not. Popular channels hardly 10 to 15. Fine. Rest of the channels are seldom used. I don't say never use, seldom use. Seldom यानी कभी कभी आप डेफिनेटली उसको ट्यून इन करते हो. जैसे गॉड है तो कोई मतलब सीनियर मेंबर अगर आ जाते हैं तो गॉड और आस्था चैनल आपके टीवी में चलता है. अदरवाइज इट इज ऑफ. यानी रास्ता बना है लेकिन रास्ते पे से कोई जा नहीं रहा. So don't you think that wireless path is going in vain? That is a void space. That is a dynamic void space that is created. Other than this, there are void spaces deliberately kept. Deliberately kept in a guard spaces. Void spaces that are deliberately kept are the guard spaces. Fine. So this somewhere has to be capitalized and this somewhere has to be utilized. Fine. Okay. So ये कब possible होगा? This will be possible when the one who is needing it should get it and the one who is not needing it, जब उसको जरूरत नहीं है वो उसने गिव ऑफ करना चाहिए. जब उसको जरूरत नहीं है. रिमेंबर व्हेन दैट पर्सन इज नॉट नीडिंग इट, व्हेन आई एम नॉट ट्यूनिंग टू अस और गॉड, माय वायरलेस पाथ शुड बी गिवन टू समबडी एल्स. वो जो बैंडविड्थ है वो किसी और को देनी चाहिए. फाइन. किसको देनी चाहिए? विच इज द एप्लीकेशन, कम ऑन, विच विल बी नीडिंग इट? दिस शुड कम फ्रॉम यू डेफिनेटली. ये आपके तरफ से आना चाहिए. यस. Come on. Which is the application that is needing it? Which is a popular application जिसमें बहुत सारे users हैं? Come on, this should come from your side. Yes. Am I audible? Anybody? Am I audible? Pratiksha ma'am, Prabhakar sir, Ritesh sir.
Yes, audible, ma'am. Audible.
Yeah. Lakshmi ma'am, which is the application which is very popular and a lot of customers are there?
For me, that screen is not moving. Your voice is audible for me.
No, screen is stagnant right now. Screen is stagnant. I'm just talking. I'm just building the foundation. It is mobile communication. Ma'am, it is mobile communication. Yes, Gayatri ma'am, it is mobile communication. Definitely. So the wireless mobile communication is the application where there is overcrowding of the customers and bandwidth is falling short. Fine. So we need to assign whichever path is available for this data to transmit. So in one application, you are having that wireless path is going in vain, and in other application there is a crowding of the data. So why not move this over this? So such type of spectrum allocation is called as dynamic spectrum allocation. Okay, fine. I'll stop sharing the screen for a moment because I'm not literally sharing. I'm just trying to build the foundation. So up till now, even in today's scenario, the spectrum allocation is a fixed spectrum allocation. Means what? You have the application and you have the bandwidth and they are tied together. Like the mobile is working with center frequency. Come on, mobile frequency. Yes. What is a mobile frequency? Come on, any of you? What is a mobile frequency, center frequency? Very simple. 800 megahertz. Fine. So it is 800, 900 band and center frequency 800 megahertz. Okay. What is another application? FM. FM is very common. So FM frequency, this is application, this is frequency, they are tied up. So this is static spectrum allocation. Currently, we are using static spectrum allocation. Means the application and the frequency are tied up. So FM frequency, center frequency, 88 megahertz. Very correct, 88 megahertz. Then the television center frequency, it is 200 megahertz. Here, what is important for us is that this is tied up, this is static. But what I am talking of, loosely bound. I mean, like you have application, you have frequency, and this is allocated to application as and when required. So the technology wherein the spectrum is allocated as and when required is called as dynamic spectrum allocation technology or dynamic spectrum allocation policy. And still we are into static allocation policy. And the technology that will make this dynamic spectrum allocation policy a feasibility, a reality, is the cognitive radio technology. So, my dear participants, we are now knowing or now coming into what is the cognitive radio technology. So, it is definitely a radio. It is definitely a radio technology. So, it will be a transmitter and receiver. It will definitely have a transmitter and receiver, but not a simple transmitter and receiver. Why? Because it has to be smart. It has to be smart. It has to be intelligent. It has to know which band is free for transmission, right? It has to know which band is free for transmission. So it is a smart technology. Okay. And it is an intelligent technology. It has to understand its operating environment, and in reaction to this operating environment, it has to configure itself. It has to accordingly adjust its parameters and be able to transmit so that it is able to transmit and receive. This is what is the cognitive radio. So now I hope you have understood what we are into. We are into the dynamic spectrum allocation policy, and what is the technology that has made it feasible. It is the cognitive radio technology. Let us move on to the screen now. Let us move on to the screen. Just see this on screen. What you are able to see. I think it's not a slideshow, right? Let me go into slideshow. Yeah. So on the screen, what you are able to see is the underutilization of the band space that I already told you ki in some spaces it is definitely, in some or very oftenly it is very it is not being efficiently utilized. What you see on the screen is the blue spaces which are 0 dB level, and 0 dB level indicates absence of signal, means bandwidth is there, the wireless path is there, but no receivers are there, no signal is flowing over that band space. Fine. And the dark spaces that you see are fully utilized spaces. However, dark spaces, brown spaces are very less, and the green spaces are the average utilization spaces. So this spectrum utilization inefficiency on spectrum utilization graph is on the screen. This is a plot by Ofcom, and Ofcom people have given us the underutilization of the bandwidth, and to make it properly utilized, what comes as a remedy is the cognitive radio. And what you see on the screen is now the definition of the cognitive radio. In simple terms, a cognitive radio is a trans-receiver device that is able to understand and react to its operating environment. This is what I told you. Now, why understand what it has to understand? Just see what it has to understand. It has to understand the propagation environment. It has to understand this propagation. See my cursor. It has to understand the propagation environment, the bandwidth over which it has to transmit, the bandwidth which is vacant. Then it has to understand, does it have the equipment capability to transmit? Because if the wireless path is different, everything will be different. What will be different? The modulator will be different. The channel encoder will be different. The source encoder will be different, and the counterparts will be different. Counterparts means the decoders will be different. So, and of course, with every wireless path will be associated its own interference. हर रास्ते की अपनी अपनी मुश्किलें होगी. Fine, okay. जैसे normal roads also, every roadway also has its different hindrances. Fine. The same way the wireless path will have its own interferences. Then am I able to bear the cost associated? Fine. Just see this, the arrow cost associated. To meet all this, if there is a lot of interference, I'll have to have a better channel encoder. Then is transmission on that path allowed? ये भी देखना है. Is it one way? Is it two way? What is it? Fine. So ये road, whatever we are following on the road traffic, the same has to be followed onto the wireless traffic. Of course, it's with its own rules and regulations. So these regulatory constraints have to be followed. What are the available systems for transmission with me? I have to check. And then after doing all this, are my user requirements being catered? ये भी मुझे देखना है. तभी मैं cognitive mode में अपने आप को switch करूंगी. Only and only then I will switch onto the cognitive radio network. Fine. And I have to see what are the other users who are along with me trying to come into cognition. So this all intelligent parameters have to be there with my radio, and then my radio has to accordingly react. And such a radio is called as a cognitive radio. Now with this, I definitely have to switch to whether you have understood. Yes, I want a yes. Yeah, I will answer to those questions. Which software? It is GNU Radio. Sir, Praveen sir, it is GNU Radio rather than MATLAB and NS2. MATLAB does have, I'll come to that. Okay, how many of you have understood what is a cognitive radio? Come on, because we have to move further for its characteristic features of cognitive radio. Okay, fine. Yeah, so first preliminary part जो है cognitive radio का वो हो गया है. Okay, fine. Okay, with this I move further on for my screen. Okay, for the one who had invented this cognitive radio is Joseph Maitola. So what you have on the screen is his definition. We need not go into his definition, but you should know who is the inventor. Okay, fine. So Joseph Maitola was the inventor, fine, of cognitive radio. In 1998, he had proposed this in one of his paper. जैसे मैं और आप paper लिखते हैं, the way in which we propose ideas and concepts in research papers might be that somebody somewhere is utilizing it and commercializing it. We never know. Fine. So Joseph Maitola had proposed this in his paper, and this has now become a to be used commercialized technology. It is being used in military applications. Okay, there is another definition to cognitive radio. It is by a forum of users or researchers like me, wherein all over the globe researchers have joined and trying to go make this technology commercially applicable. Okay, fine. So the SDR forum defines it in what is stated on the screen: a radio that has, in some sense, awareness of changes in its environment. Again, the same, it has to be have the intelligence to know the changes in its environment. Now, and not only that, in response to these changes, adapts its operating characteristics in some way to improve its performance or to minimize a loss in performance. Now there is a feather in the cap. SDR forum is putting a feather in the cap. Just see. Feather in the cap means what? When we have a higher band space, if you have a higher band space, definitely रास्ता अगर बड़ा है तो हमको वो रास्ते, जो बड़ा रास्ता मिला है उस पे स्पीड से गाड़ी दौड़ाना चाहिए, राइट? डू यू एग्री और नॉट? इफ द रोड स्पेस अवेलेबल इज बिगर, फाइन, don't you think we should increase our speed? If the road speed is wider, I should say, don't you think we should increase the speed? Yes, definitely. जब लेकिन speed बढ़ाते हैं तो क्या होता है? There are chances of, come on, accident. और wireless में accident is packet loss. Fine. So there will be errors. So you should have the encoders with you to correct all the errors. The moment you increase the speed, what will happen? There will be more errors. And if there are more errors, you should have better channel encoders. And you can have it because you can add more and more redundancy. Channel coding is adding redundancy. And why redundancy can be added? Because channel width is more. Okay, fine. So this is what the slide is talking of. Improve the performance. So as to improve performance or at least minimize the losses. Now this minimize the losses means what? Okay, sometimes you will get a wider space for transmission because I'm talking of dynamic spectrum allocation. कभी आपको चौड़ा रास्ता मिलेगा तो कभी आपको narrow path मिलेगा. तो चौड़ा रास्ता मिला तो ठीक है, performance improve होगा भाई. लेकिन if the pathway is narrow, then what? Then what? There has to be data compression. But compression to what extent? So that we should minimize the losses. Means what? It has to use a better, which coding technique? Which coding technique? Yes? Channel coding for meeting the errors. The other technique is, कौन सा coding होता है जो data को compress करता है? Come on. Which coding technique compresses the data? LZ, yes, source coding technique. Okay, so all source encoders, so better source encoders need to be incorporated to compress the data so as to minimize the loss. Any compression is losses, but then those should not be audible, visible losses. Okay, तो human anatomy को ध्यान में रखते हुए जो कोडर्स बनाए गए हैं, जैसे कि हफमन कोडिंग is taking advantage of the interdependency of the symbols. Fine. Probability of occurrence of U after Q is high. Fine. तो U को discard कर दो, Q को ही भेजो. Q, U, E भेजने की जरूरत नहीं. Only letter Q is sufficient. Fine. So this is what is Huffman coding. Okay, fine. तो ये जो है इसका एडवांटेज लेके जो सोर्स कोडिंग टेक्निक्स बनाए जाएंगे, फाइन, they will help to minimize the losses. So this is what SDR forum is saying, कि even if we have a smaller bandwidth to transmit, a smart cognitive radio should use a better encoder to send the data. So this is what SDR forum says. Okay, fine. Let us move on to the further characteristics, the types of the cognitive radio. I hope I am clear with the definition. Now we can go into the various ways into in which we can get into cognition. देखो कैसा है, कॉग्निटिव एनवायरमेंट एक एनवायरमेंट है जिसमें हमको जाना पड़ता है. फाइन, वी हैव टू go into cognition. So there are various ways, approaches to go into cognition. इसके लिए ना you need to I need to take an example. I need to cite an example, which is the costliest commodity in day-to-day life. It is the house, right? If I have a flat, fine. If I am having a flat in Nagpur, fine. And since I am a government servant, I am transferred after every 3 years. So मेरी transfer Pune हो जाती है. So definitely I have to shift to Pune. So do you think that I will leave my अब ये without PPT I will please connect to me. Please see your screen. I will again stop sharing and look onto your screen because you need to look at me. Fine. So मेरे पास मेरा अपना घर है. Fine. Nagpur में. I have my home at Nagpur, but I am shifted to Pune. Okay, because of my transfer. Now, do you think I should keep my flat, my house in Nagpur vacant? Come on, yes or no? Costliest commodity कौन सी है भाई आजकल के जमाने में? घर. So, do you think I should keep it vacant? Yes or no? Come on. Renting, very good. Yes, I got a very nice answer. Renting. Exactly, this is what the wireless path holders, यानी license band holders. देखो wireless path जब हम खरीदते हैं तो हम उस path के license holder बन जाते हैं. It is called as a band license to that application. Sony का अपना band है, Star का अपना band है. Fine, okay. So they are the licensed users. Now, if Sony is not utilizing it, if God is not utilizing it, the God channel will rent it to the mobile users. Okay, fine. अब ये जो renting है, अब ये renting किस तरीके से होता है देखो कि मुझे पता है कि भाई मैं साल भर में मैं आऊंगी नहीं. I will take at least 1 year for getting back transferred to Nagpur. Fine. So what I'll do is I will tell the person कि भाई for a year or for 6 months, for a year, whatever it is, आप रहो. But whenever I am transferred back, immediately you have to vacate. Okay? याने cognition में आने का तरीका देखो कैसा है कि I am the landlord, the licensed user of that space. Okay, fine. And the one who is renting it is called as a secondary user. उसको क्या बोलते हैं? Secondary user. So the mobile user becomes a secondary user. The God channel holder becomes the primary. Fine. तो ये जो primary है, license user जो है, वो बोलेगा कि भाई fine, when I am not there, you utilize the channel. So this is one approach. This is one approach. However, when I come back, you leave it. You vacate it. So this approach is called as interweave approach. Interweave approach is an approach wherein the secondary uses the primary band only when the primary is not needing it or until it needs it and immediately vacates the band as soon as the primary peeps in. Okay, ये एक याद रखो. Fine, this is first one. This is interweave approach. Okay, अब दूसरी situation. Just go to the example again. अब मेरा बेटा जो है, my son is studying in Nagpur. So if my son is studying in Nagpur, my frequency of coming to Nagpur will be definitely lesser than more than the 1 year gap. I will definitely come to Nagpur to visit my son once in month or might be after every fortnight, 15 days में एक बार. Okay, ये भी हो सकता है. तो इस situation में what should I do? Come on, should I rent the complete flat? Yes. Come on, interactive. It should be interactive. Should I rent? No. What should I do? One room or something I should keep for myself. Shared. Yes. I should partly rent it. Partial renting. Yes. I should partly rent it. So this second, we are moving to the second approach. Second approach में हम क्या करते हैं कि the primary and the secondary can simultaneously use the band. Okay. However, कैसा है कि ये जो secondary है, it has to keep its power below a certain level, because when two wireless signals are transmitting on the same band space, definitely they can cause interference. Fine. So the secondary has to limit its power. सेकेंडरी को पावर, इसको उसी एग्जाम्पल से समझाती हूँ कैसे. देखो कि वो जो है स्टूडेंट्स है, मान लीजिए मेरे घर में रहने वाले जो है वो बच्चे हैं, फाइन, जो रेंट में रह रहे हैं, तो मैं नहीं हूं, तो दे हैव फुल फ्रीडम टू डू व्हाट दे वांट, ट्रांसमिट एट व्हाटएवर पावर दे वांट. Okay, full freedom. However, when I am there, they have to keep the volume down. They have to be in discipline. उनका पावर उनको जरा कम रखना पड़ेगा मेरे प्रेजेंस में. तो सेम इज द केस. व्हाई? बिकॉज दे विल कॉज एन इंटरफेरेंस टू मी, दे विल कॉज अ ट्रबल टू मी, डिस्टर्बेंस टू मी. तो सेम इज इन द केस ऑफ वायरलेस कम्युनिकेशन. सेकेंडरी कैन कॉज डिस्टर्बेंस टू प्राइमरी. सो इन सेकेंड अप्रोच, whether primary is present or not, secondary can utilize the primary bandwidth provided it does not cause any interference to the primary. अब देखो इसमें कैसा है, पहले इसमें हमको कंटिन्यूअसली सेंस करना पड़ रहा था कि प्राइमरी को जरूरत है कि नहीं. वी हैड टू अंडरस्टैंड वेदर द प्राइमरी इज रिक्वायरिंग द बैंडविड्थ और नॉट. लेकिन यहाँ पे वैसे नहीं है. वी कंटिन्यूअसली डू नॉट हैव टू चेक इट. We just have to keep a limit on our powers. The moment it is present, we have to limit our powers, and we can still transmit. We don't have to cut down our transmission. Okay. So the spectrum, I mean the multiple access techniques will change, will be accordingly changing over here. Simultaneous transmission is possible. Only thing is that you have to limit the secondary power. So this is second type of approach. पहला था interweave, दूसरा है since it is transmitting below a certain threshold level, therefore it is called as underlay approach. Second approach is called as an underlay approach. I hope the second approach is clear. We'll move to the slides. Okay. अब तीसरा approach भी है. अब तीसरा approach ऐसा है. Again we'll move on to the example. भाई वो जो बच्चे हैं ना जिनको मैंने रेंट से दिया है, the students who have rented my house are music students. If they are music students, they will practice music. If they are practicing music, they shouldn't be bothered whether I am present or not, because it is their profession, it is their study. They have to practice, right? So my presence should not limit their practicing, and it should not even cause interference to me. So what do? They ask me that, ma'am, we will make this room a soundproof room. One of the room, a soundproof room. So they are adding to my assets. What they are doing, they are doing an addition to my signal. So same is the case in wireless transmission. Wireless transmission में presence of the secondary with the primary is lowering down the S/N ratio, signal to noise ratio. Noise for the primary, the signal S, fine. The secondary power is N. Noisy है ना वो, signal to noise ratio hamper हो रहा है. तो now what will the secondary do? जितना उसने कम किया है S/N, उतना ही S/N वो बढ़ाएगा. कैसे बढ़ाएगा बताइए? S/N लोअर हुआ है N बढ़ने की वजह से, तो S/N फिर से मेंटेन कैसे होगा? How will S/N be maintained? Come on, anybody. See, we have to keep the S/N intact. I hope all of you know the communication basics. How, if N is increasing, to maintain the S/N, S should increase. Amplifying, yes. So this amplification, this very good, Gayatri ma'am and Ruhina ma'am, this amplification of the primary signal is done by the secondary. A part of the secondary power is utilized to boost the primary signal, and thus the S by N that has had lower down is maintained. Fine. So this third approach does not at all have to worry about the presence or absence of the primary signal. It only has to share a little power to boost the primary signal. And this approach is called as overlay approach. Why? Because secondary को कोई tension नहीं है कि whether the primary is present or not. Fine. So we have learned 3 approaches: interweave, underlay, and the overlay approach. Fine. So let me again share the screen. So interweave, underlay, and overlay approach. These are the various ways to get into cognition. So what you see on the screen is the interweave approach. Please forgive me for that spelling. It should be interweave, not interwave. So what you see on the screen, the dark reddish color spectrum plot is of the primary, and the green ones are of the secondary. In the third graph, see my cursor, this has left because this has peeped into. The primary has peeped into. Somebody please answer. Are you able to see the cursor as well?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. Okay, then you have the definition of underlay. Allows the cognitive users to operate on a certain frequency band, either unoccupied or not, provided that the interference caused to the primary users remains below a fixed threshold. Fine, I hope that is clear. The overlay approach, a part of alpha PS is the alpha is the part, fine. A part of the secondary is given to the primary to boost the primary signal, and thus a compensation of the fall in the S by N is made. The cognitive user employs part of its power to maintain or improve the primary user's performances so as to compensate for deterioration due to its own transmission. So this is the overlay approach. Now, what you see on the screen is the types of the cognitive radio. Now, when you know a certain technology, you should know it to its entire depth. So then and then only you can do the modeling. क्योंकि अगर आपको agriculture के लिए cognitive radio use करना है, तो कौन सा use करोगे आप कौन सा cognition method use करोगे, कौन सा type का use करोगे? Fine, ये सब पता होना चाहिए. Therefore, I am giving you all these basics. Okay, fine. So various types of cognitive radio network. देखो कैसा है कि when we are onto Samruddhi Mahamarg, fine. So if I am onto Samruddhi Mahamarg and I am having an SUV vehicle, so I will follow all the protocols of Samruddhi Mahamarg. Means I will stick up to this lane, I will stick up to the speed. Why? Because I am fully equipped with the requirements of that Mahamarg. So such means all the TCP/IP protocols are being followed along with transmission on that path. Okay, so this is called as full cognitive radio, and also to give it the honor to the inventor, it is called as Maitula radio. Okay, fine. Yani, when we are adapting to a path along with all its protocols, following its all protocols means what? The speed, the frame size, the frame pattern, the encoding encryption structure, all that comes in TCP/IP protocols. Computer people will better understand this. Okay, then comes the second type. Now if I am onto Samruddhi Mahamarg, but I am having a Maruti 800. Maruti 800 maximum speed 120, वो भी vibrate होगी 120 पे. So in that case, what I will have to do? 120 नहीं, 100 ही है भाई, 100 ही है. So I cannot go to that high speed track. I'll have to keep the truck lane. Fine. Means I am not adapting to the protocols of the Samruddhi Mahamarg because I am having a lower side vehicle. Fine. Okay. I do not have the equipment capabilities. So I'm just utilizing that path because no other path is available. Okay, but I am keeping my own protocols of transmission. Fine, data rate, data speed, sab mera rahega. So if this is done, then it is called as spectrum sensing cognitive radio. Means I have sensed the spectrum and I'm utilizing it, but as per my formats, not the formats, not the protocols of that path. Okay, then there are other two. Now other two are very simple to understand. If I'm utilizing a TV band space, it is a licensed band space. Therefore, it falls under license category. Radar, TV, all forms under the license category. There is another unlicensed category, ISM band. Can anybody tell me what is the full form of ISM? Yes, ISM. Anybody? Chat. Full form of ISM. ISM band is a free band. What is it? Come on. Interactive. It should be interactive. Industrial, scientific and medicinal use. Very correct, sir. Very correct. So my friend Ganar sir has given the right answer. So this is a band space left free for the industrial, scientific and medicinal use. Okay. So if anybody is tuning to that band and the guard spaces, even guard space may be transmission ho sakta hai. Fine. The space between two allocated band spaces, two application allocated band spaces is called as a guard space. Uske beech mein bhi transmission ho sakta hai. Agar aisa transmission aap kar rahe ho, so that is called as the unlicensed band cognitive radio. Okay, fine. So this is the various types. Now आपके रेडियो को कॉग्निटिव कहने के लिए कुछ इंपॉर्टेंट फंक्शंस आपके रेडियो ने करने चाहिए. व्हाट आर दीज फंक्शंस? सो दीज फंक्शंस आर ऑन द स्क्रीन. ये फंक्शंस जो है वो स्क्रीन पे है. ओके, see what are the functions. So पहला सबसे important function that your radio should do is the spectrum sensing. Definitely it has to sense the spectrum, and there are various ways in which various methods to sense the spectrum. They are the transmitted detection, the cooperative detection and the interference based detection. इसमें से कोई भी मेथड आप लोग यूज कर सकते हो. When you are into depth study, you will understand what are these methods. Okay. फिर दूसरा जो है, एक बार सेंस कर लिया कि कौन सा रास्ता खाली है, which path is empty, then you should understand whether you are really able to transmit on that. Do you have the equipment capabilities? तो उसके लिए वो रास्ते को समझना जरूरी है. You have to know the hindrances on the path. Fine. You have to know whether it is a Mahal way or whether it is a Samruddhi way. Fine. Mahal में आप SUV लेके जाओ, देखो क्या होगा. Fine. Just it is that as simple as that. You go in Mahal with a SUV, see what will happen. And on Samruddhi, you go with a two-wheeler. What will happen? So that is it. You understand what is the path like, what are the hindrances on the path, what is the interference. So what you have to do, you have to analyze the spectrum. Fine. So channel estimation techniques use करके you have to analyze the spectrum and then you have to decide whether you are going to use it or not. So this is called as spectrum management. ये important function आपके radio ने करना चाहिए. Then the third one, spectrum mobility. ये बढ़िया है. This is very beautiful. See, now this you need to understand with the example that I had cited, the house on rent. Fine. Okay, fine. He has to vacate the house. But then if a person is taking a 4-year degree course, if students are taking a 4-year degree course, he has opted for my house because his college was near, can he shift to a different locality? No. He has to find out a house in nearby. तो जब वो rent से लेता है ना मेरा घर, तो तभी उसने ये सारे probability estimations किए हैं. He has done all these probability estimation quite in prior hand. That what is the time that I'm going to come back, and after 1 year, what is the possibility of getting a vacant house, a vacant flat or vacant room in the nearby locality, because he's already adjusted to that locality. His workplace, his college is near that locality. Though same is the case with your radio. Your radio is transmitting in 200 megahertz, so it can shift to 250, 230 megahertz. It cannot abruptly shift to 88 megahertz. Fine. So spectrum mobility is shifting the spectrum when the second primary has come into. Fine. So this is what is, and this has to be done seamlessly. Now in current situation, Shifting from one mobile space to another mobile space is difficult. हम जब ट्रेन में होते हैं तो हैंड ऑफ जो है वो मुश्किल से होता है. We very often lose the connection. We do not hear the in between words. So I am talking of spectrum handoff. फाइन कि एक स्पेक्ट्रम से दूसरे स्पेक्ट्रम में हमको जंप करना है. सो स्पेक्ट्रम मोबिलिटी फॉर सीमलेस यानी विदाउट ब्रेक कनेक्टिविटी. दिस इज अनदर इंपॉर्टेंट फंक्शन दैट योर रेडियो हैज टू डू. एंड द फोर्थ वन इज अ फेदर इन द कैप. अ फेदर इन द कैप यानी क्या कि भाई मेरे घर में, मेरे फ्लैट में 2 बच्चे रह रहे थे, रेंट था 15,000. ओके, after few days the students understood 15,000 is becoming too high for them to be paid by 2 students. So 2 more students join with them, 4 are being utilizing the house. Fine. However for this they have to take permission from me and they have to increase the rent from 15 to 17, say. Fine. Okay, so rent is increased for me, is my advantage, and the additional trouble of managing the other 2 is being taken by the first secondary users. So secondary creation एक होता है जहाँ पे subletting होता है. So my house is being sublet by the first two tenants. Okay, fine. तो स्पेक्ट्रम शेयरिंग इसको कहा जाता है. सबलेटिंग का कंसेप्ट है. दिस कॉल्स इनटू ट्रेडिंग ऑफ द स्पेक्ट्रम, जिसमें बहुत सारा बिजनेस, बहुत सारा मार्केटिंग इन्वॉल्व रहेगा. फाइन, बट दिस इज अ फेदर इन द कैप. इट्स नॉट अ इसेंशियल फंक्शन. सो दीज आर द मेन फंक्शंस ऑफ द कॉग्निटिव रेडियो. कितने लोगों को कॉग्निटिव रेडियो समझा है? कम ऑन, नाउ आई नीड टू टेक अ पॉज ओवर हियर. With pause in the sense, just a 1 minute pause with a discussion with you. How many of you have understood what is a cognitive radio? What are the types of cognitive radio? What are the various approaches to get into cognition? And what are the... Yes? Okay, fine. You have understood. Very good. Yes. What are the main functions? That is where we stopped. Okay, fine. So you have understood what is a cognitive radio. Now let us move on to instead of going on to the performance improvement and all, we will come to our topic. So I need to share, I need to come to this. Fine. Is my screen visible? Now this is switching to our topic. What is visible on the screen? What you have is the sensors that are needed for the agriculture purpose, right? Am I right? Yes or no? Anybody saying yes? Yes? Anybody can just turn on the mic and say yes. Are you able to see the screen?
Yes, ma'am.
Okay.
Yes, madam. Yes,
So
madam.
this is a very familiar what you can say slide, which very often we see for our student projects. Fine. So where we have the temperature sensor, we have the pH sensor, we have the soil moisture sensor, we have the microcontroller. Very often students go for that Arduino Uno. Fine. Then we have the PIR sensor, humidity sensor, and then what I will show further is the overall system. Fine. The architecture for this sensor, smart agriculture system. Here you have all the microcontroller at the center, and you have all those sensors connected. Fine. Now, after this is called as a data acquisition system. Do you agree with this? This is a data acquisition system, right? अब data acquire तो कर लिया, sensor से data acquire कर लिया, मेरे system में आ गया. अब what next? They have to be routed. Fine. Routing के लिए क्या लगता है? See the connectivity now. Now see the connectivity. For routing, what will be required? You say you will put it on cloud. You will do this, you will do that. But do you have the internet facility? Now I will stop my sharing over here for a while. So do you have the internet connectivity in all places, in all rural areas? No. So what is the solution? What is the solution? If I am into, because agriculture you see is in rural areas. वहाँ पे cabling नहीं होता है, वहाँ पे इंटरनेट फैसिलिटी इज वेरी रेयर, फाइन. वाईफाई ठीक है, मिल जाएगा, वाईफाई आपको मिल जाएगा, फाइन. सो वाईफाई नेटवर्क्स आर अगेन कमिंग इनटू एडॉक नेटवर्क्स. सो कॉग्निटिव रेडियो एंड एडॉक is very much interlinked. Basically, cognitive radio networks are ad hoc networks. Why ad hoc networks? Because temporary hai. They are for momentary, for using for certain application. Once that application is over, वो network path, वो network connection जो है, वो उसका that does not remain over there. Fine, it is established for a particular purpose, and that is what is ad hoc. Fine, okay, purpose networks adapted or implemented for a certain purpose which have existence for a short period are ad hoc networks. Fine. Cognitive radio mein you have a what you can say establishment of a ad hoc network wherein you have the base station transmitter which takes the backhaul from the satellite, all the data from the satellite. Backhaul means what? All the data from the satellite, and it transmits to the cognitive users. Fine. तो ये जो है cognitive receivers, fine, the secondary receivers. So ये जो होता है आपका ट्रांसमीटर जो होता है, ये क्या करेगा कि वहां पे आपको सबस्टेशन एस्टैब्लिश करना पड़ेगा. It is a small this kind of a unit, fine, where you have a transmitter and you have the client receivers. Fine. So what will the client receivers do? They will have the data acquisition system. They will acquire the data, put it on the wirelessly established network for that region, and the farmer sitting at his home will be able to view that, will be able to do the necessary activities based on whatever data is acquired. Fine. So data acquisition system सिर्फ डेटा एक्वायर करेगा, लेकिन कॉग्निटिव रेडियो क्या करेगा? विदाउट द रिक्वायरमेंट ऑफ एनी स्पेशल कम्युनिकेशन नेटवर्क, कि वहां पे कोई बीएसएनएल का टावर नहीं है, कोई ये नहीं है, वोडाफोन का टावर नहीं है, कोई इंटरनेट फैसिलिटी नहीं है, लेकिन आपका कॉग्निटिव सेटअप वहां पे हुआ है. कॉग्निटिव का अपना बेस ट्रांसमिशन स्टेशन है, बेस रिसीविंग क्लाइंट्स हैं, वो अपना ट्रांसमीटर रिसीवर सेटअप है. वो क्या करेगा कि ये डेटा एक्वायर करके यहाँ पे भेजेगा. दिस विल रिस्पॉन्ड, इन रिस्पॉन्स टू दैट data acquired, will send signals for the activities in the farm. Have you understood what is the role of cognitive in the smart agriculture? The role of cognitive in smart agriculture is to provide the necessary communication when there is no form of existing communication in the land space. Existing by popular communication techniques. कौन से? The existing networks, the popular networks नहीं है, आपका इंटरनेट फैसिलिटी नहीं है, जो आप बोलते हैं क्लाउड पे डालेंगे, मोबाइल पे आएगा. कैसे आएगा मोबाइल पे? क्योंकि नेटवर्क ही नहीं है. तो वो नेटवर्क उनको कौन देगा? ये देगा. कौन देगा? योर cognitive ad hoc network will do. And the same mobile, सबसे बड़ी खासियत क्या है? The same mobile, the same number will, ये कैसे होता है? This is SIM cloning, or what you can say, the backhaul data extraction from the satellite. This is also useful not only in the agricultural land but in dense forest areas. Dense forest areas में वो gypsies होते हैं ना, gypsies पे आपका ट्रांसमीटर यूनिट होता है, और जो ट्रैकर्स जाते हैं, ट्रैकर्स यानी जो वो थीव्स के पीछे, जो टेररिस्ट के पीछे लोग जाते हैं, उनको कहा जाता है ट्रैकर्स. They go on bikes, they don't go on gypsies because the forest is dense. Gypsy after a certain level cannot penetrate. तो ये जो ट्रैकर्स होते हैं, ये ट्रैकर्स आमतौर पे वहां पे सिग्नल नहीं आता. वाईफाई या इसका तो सवाल ही नहीं है, इंटरनेट का. वहां पे सिर्फ सैटेलाइट कम्युनिकेशन पहुंच सकता है अप टू सम एक्सटेंट. सो बैकहॉल वो इरेक्शन से सैटेलाइट से ले लेता है, एंड the connection of this gypsy with the riders is there, and therefore the riders can be traced and information from the rider can be obtained. Otherwise पहले ऐसा होता था कि जो ट्रैकर dense forest में जाता था, the tracker, those used to go into the dense forest, either they used to be killed by the terrorist or the or the animals in the dense forest. Okay, यानी एक बार चले गए तो very often they used to never come back. This was the tragedy with the wireless, that the wireless SP had explained to the Amitech people. Fine, Amitech is a company. I'm not doing any promotion of the company, but it is one of the company who is very fruitfully utilizing this cognitive radio technology with its SDR, fine, software defined radio, which is the heart and soul of this cognitive radio. Usse ye implement kar raha hai for DRDO as well as for the wireless SPs of the region. Okay, fine. So this is the way cognitive radio is going to establish the smart networks for its use in smart agriculture. Now let us move on to the takeaways and the benefits. So quickly we'll come to, since we are heading to the noteworthy from this. Definitely it is an intelligent, it requires a lot of artificial intelligence, cognitive radio network. So the use of cognitive radio in fact is what makes the agriculture smart. Kyunki isme intelligence dalega kaun? The intelligence will be put by the cognitive networks. Fine. And different from the one which is existing. More and more structured algorithms and use of ML will make cognitive radio sensor networks a commercial feasibility for agriculture. Abhi nahi hai. Okay, fine. We are thinking of. So these are the references. Fine. So before I conclude, I have a question. You can give your answer in the chat box. Would you like to visit a pond or sit beside a pond, or do you like to visit a river, and why? Fine. Come on. एक क्वेश्चन है आपके लिए. आप पॉन्ड साइड विजिट करना चाहोगे या रिवर साइड? Yes, river side. Why? Because it's a flowing water, lot of hurdles, and what makes that river beautiful? What makes the river beautiful? The river is made beautiful because of the stones in the river, the huge stones and the splash of the water over those stones. So the hurdles in your life, the challenges in any technology makes that technology a real research technology and a workplace for the researchers. Fine. Yes, beautiful landscape, and the same is the case with the cognitive radio. It's really beautiful place to work into, and its application are wide and vast, and lot of scope for researchers to work. I could explain only half part of it because there were time constraints. I was given 1.5 hours. I have a small video to summarize the concept. So with permission of the organizers, I would like to play it.
Sure, ma'am.
Definitely, madam.
Yeah. I hope my screen is still visible.
Yes, ma'am.
Okay. Just wait.
Screen is not visible.
Screen is not visible?
No, ma'am.
Okay. Just a minute. It is audible as well and visible as well now?
Yes, ma'am.
Okay.
Now it's visible.
Basil takes his dog Pepper for a walk at the marketplace. Basil needs to buy a new collar for Pepper. While Basil is not paying attention, Pepper wanders off. He finds an enchanting collar on the ground. The imperial servant assumes Pepper is one of the princess's many pets and lifts him into the carriage. When Basil sees what's happening, it's already too late. He is not allowed to use the imperial lane because of the strict traffic rules. This is in fact exactly how wireless communication works today. Mobile devices are only allowed to use certain frequencies, which are getting crowded. New music and video services on the internet require far more bandwidth than is available for the current networks. With cognitive radio technology, we can use all available frequencies, even those dedicated to TV or satellites. The intelligent devices negotiate in order to use the whole radio spectrum in the most efficient way. This way, we can multiply the current network speeds. Basil arrives at the town gates. But to enter the town, he has to fill in a stack of forms. He has no time for this kind of nonsense. But hey, what's that guy doing there? He's filling out all the forms just by the push of a button. With cognitive radio, you can easily control and verify your identity, both online and offline, in one simple step. For instance, when you move, you could redirect your mail, subscribe to electricity, gas and water, enroll your children at a school, and even register to vote, all at the same time. Although your device is capable of connecting with any institution, you would still be in charge of the information you choose to share. Basil comes across a billboard advertising an event at the arena. He can't understand the language, but the radio-enabled billboard sends his handset the information he needs, which he then shares with his friends. By the word radio, we mean any kind of wireless communication. At the moment, radios can communicate only with other radios of the same kind. Cognitive radios could understand the language of any radio. This, combined with new simple radios embedded in any object, would allow interaction between any physical objects. This could also provide solutions for communication between people of different languages and cultures. At the arena, Basil sees Pepper in the imperial box with the princess. Basil hears somebody coming. Suddenly, Basil has become a part of the main event. He can't even lift his weapon. Running for his life, Basil pushes the panic button on his device. At a concert, a football game, or any big event with tens of thousands of people, the local network may get overloaded. With current spectrum usage limitations, the provided capacity just isn't enough for all the users. Cognitive radio can use all available frequencies and connectivity methods. It can quickly adapt to the unusual situation and ensure proper operation of the networks. The devices connect not only through the network cells, but also by forming spontaneous networks. This way, messages, phone calls, and even real-time video streams can be transmitted by many more users. One of Basil's friends finds information about the lion. This gives him an idea, and he tells everyone about his plan. Light distracts the lion from the chase. Basil suddenly realizes this may be his opportunity. Success! The undefeated lion is caught. Basil has done the impossible. Basil is escorted to the winner's lounge to wait for the princess. Here she is, Her Imperial Majesty. Oh dear, this won't go well with the princess.
So that was all from my side. Any queries? There were questions in between, which I did read. So MATLAB does have a cognitive engine design available, but the hardware interface of MATLAB is a little bit slower. So the most suitable software is GNU Radio. GNU Radio has a very good interface with SDRs, so that is more preferable. Yes. Anything else? There was something multiplexing technique regarding it was there. So it depends upon which approach you are going for. Fine, if the multiplexing technique will be depending upon the approach that you are utilizing. Yes, and any other questions? I hope the video explained it. There was a revision with the video.
Yes, ma'am.
Yes.
Yes, any more questions, audience? Queries, if any participants, please.
Good evening, ma'am.
Yes.
This
Yes.
is very informative session for us.
Thank you, sir.
And a new learning, I would say, because I am not from the network.
Okay.
Yeah. But,
Yeah,
is there any live application or some communication devices are available here?
Yes, sir. Yes, sir. Like, see, you see the walkie-talkies. Walkie-talkies are also used in programs. Then walkie-talkies are used in event managers use walkie-talkies. Then the military persons use walkie-talkies. So walkie-talkie can connect anytime and every time. So it literally searches for a bandwidth, which we do in cognitive. It is a cognitive radio, and it communicates on whatever bandwidth is available. So that is a specific application of cognitive radio.
Okay, and can it be utilized in the IoT devices?
Certainly, sir. Certainly. See, IoT is in-network communication. So cognitive radio has its own base transmitter station, transmitting station, and a receiver station, transceiver station. So it does not have to depend upon any other network availability. So definitely, if you want to establish 100% connectivity in IoT in absence of network, cognitive radio perhaps is now the only available solution. In absence of, the most preferred is, sir, the internet.
Okay.
Yeah.
Thank you, ma'am.
Yes.
Thanks.
Between
looks
SDR
like,
and CSDR. Okay, fine. SDR is software defined radio, and I am definitely not aware about CSDR, but SDR is software defined radio. It is the hardware part of the cognitive radio, generic hardware part, wherein you have the LNA, low noise amplifier, and an antenna. Rest of the entire communication part, that is your source encoder, channel encoder, modulator, is a software. Fine. And this only a generic hardware is there. So a combined software with this generic hardware forms the SDR, software defined radio, in which almost all functions are performed by the software. CSDR, I am not aware of. I have to read, sir. What is CSDR? I have to read. Rahil sir had asked that on the chat box.
Yes, any more questions, sir? Participants, any more questions?
I think in the rural areas, so it will be very much useful, and it is very much useful in the IoT devices applied in the remote areas.
Certainly, sir. Sir, I have filed and published a patent which is on the stage of granting, wherein we have proposed a smart voting machine. Very often terrorist areas and other areas, people like we are appointed as polling officers, and वो सारे जो होते हैं ना आपके बूथ पे, तो we are afraid of going into such areas. So वहीं पे सिर्फ वो आपका जो स्मार्ट वोटिंग मशीन है वो डिप्लॉय किया जाएगा, एंड दैट वोटिंग मशीन इटसेल्फ विल टेक केयर ऑफ द स्मार्ट वोटिंग मशीन विल टेक केयर ऑफ द एंटायर प्रोसेस. इट विल नॉट neither need your mobile network, nor it will need a internet facility. It will only need a establishment of cognitive ad hoc network prior to the election, and entire voting process will be managed by the local people there itself. This is a patent under granting. It is already published.
Okay, will
Madam,
it communicate with the satellite networks?
Yes, satellite से ही backhaul लेता है sir वो. Satellite से ही backhaul लेता है.
Madam,
Thanks.
to access from the satellite, they may require towers. in the
Yes, a
rural
tower
area?
erection is there. A tower erection is there. That is what I'm talking of, a ad hoc establishment of base transceiver station.
Okay.
It is of the height of at the most 5 feet. 5 feet height.
Okay, okay.
Yeah. This was demonstrated in Ramdeva Engineering College, and we communicated with, and it came into our mobile में जो net आता है ना ऐसे कि Vodafone network, K network, तो उनके नाम से वो आया, जिस कंपनी का था उनके नाम से वो नेटवर्क आया. Yes.
I think earlier rural people used to access the phones and all through these towers. The tower size might have been reduced now.
Yes.
Earlier tower was bigger size.
एक कौन सा तो एक ham radio kind था sir, आपको याद होगा.
Yeah.
It is just an advancement of the ham radio.
Yes.
Exactly. Yes.
Madam, you made the subject very simple to us, because I am not an engineer or not a technical graduate. I am an agriculture graduate, and I could understand the subject also. Thank you so much.
Thank you so much. Thank you so much. That means a lot. Yeah.
Yes. Any more questions?
Good evening, ma'am.
Good evening,
Ma'am,
sir.
it's really a very nice presentation. My query is not very much technical. This is little bit commercial, ma'am.
Okay.
Like as you mentioned that this technology is presently one solution for transmitting the information, right,
Yes.
ma'am?
Yes.
If any business organization communicated with us,
Huh.
that how they will that means execute this process, then what suggestion we will give to them, like machine procurement or tower erection, or what suggestion we have to we will give to them, if any organization willing to like implement AI based farming.
Yes, I got it. From commercial aspects you're talking. So let me tell you, sir, a complete cognitive radio network setup along with the base station establishment is a cost affair of around 12 to 15 lakhs, depending upon the range of transmission. If the range is more, the tower has to be a high power tower. But again, there is limitation in the power because it should not interfere with the existing networks. Existing license network, because this is an ad hoc establishment. So एक simple सा experimental setup तो 3 lakhs में आ जाएगा, लेकिन अगर आपको commercialize करना है उसको तो for a work purpose it will definitely be a cost affair of around 12 to 15 lakhs.
मैम ये हम कहाँ से ले सकते हैं?
सर जो कंपनीज मुझे पता है that is Emitech New Delhi, sir. Emitech New Delhi is deploying, has already done it for DRDO and for the wireless SP department.
Okay. Thank you
Yes,
so much.
Delhi,
ma'am.
New Delhi, yeah.
Do we need the some regulatory authorities?
Yes,
permissions
we
for
have.
that also?
We have to inform to the local BSNL, BSNL providers, because they ensure the testing, the SAR testing karte hai wo, and they ensure that it is not interfering with the existing wireless networks.
Okay, thanks.
Yeah.
Yes. So thank you so much, ma'am. We have people here from non-engineering backgrounds as well, but still I think your explanation, I believe, must have made it very easy for everyone to understand.
Thank you. Thank you for
And-
making me a
And
part.
also the video shown,
Hmm.
recall the entire session conducted.
Yes.
It is always a pleasure learning things from you, ma'am. So thank you so much for a lovely interactive session. Thank you so much.
Thank you so much. Thank you.
Yeah,
Thank you. Good night, ma'am.
Thank you.
Good night. Good night. Good night. Yeah. Thank you.
I think our next speaker has already joined. Pallavi Chauhan, ma'am.
Madam, yes, she joined, but wait for 1 or 2 minutes.
Okay. Fine. Fine, sir. Participants, please stay connected. Ma'am is already there and she'll be starting in a minute or two.
Yes, madam, we can start.
Okay.
Hello, good evening.
Yes. Good
Am I
evening.
audible, ma'am?
Yes, yes.
Yeah.
Good evening, ma'am.
Yeah.
So the next session for today's program is on role of IoT in disaster management. And this will be conducted by Dr. Pallavi Chauhan. Ma'am is working as a professor and head at IT department, right? DFI Patil, deemed to be University, Navi Mumbai. She has been in academics from last 21 years. In her career, she worked with different domains like visual cryptography, intelligent systems, machine learning, and data science. She extended her contribution with 45 research papers in international journals and conferences, including Springer, Science Direct, Endoscience, and IEEE. She has 7 books and 1 patent to her credit. She's also the recipient of grants from UGC, CSIR, AICTE, and Mumbai University. 2 research scholars have successfully completed PhD under her supervision. Currently, she is guiding 5 research scholars at PhD level. She is actively involved in the research activities. Her firm belief is teaching is a mission. So we welcome you, ma'am,
Thank you.
and we request you to kindly continue with your session.
Yeah. Just ensuring whether my screen is visible to you.
Yes.
Yeah. Thank you. So, good evening to all the participants and the organizers. This is a session related to Internet of Things, disaster management, and some artificial intelligence and machine learning techniques to get smart solutions to deal with the disaster. So this will be like a session with few glimpses of disaster management and solutions for the disaster management. Then how exactly sustainable development is taking place and what is the role of IoT in the sustainable development, how we are coming up with the smart IoT solutions for dealing with different kinds of situations. More focus will be given here in this session on the waste management techniques and how we are coming up with the smart waste management system, and finally in detail 1 or 2 techniques of AI to come with the smart solutions. So this is a very introductory slide indicating that if we need to define different phases in some emergency kind of thing, how those phases will be aligned. Like if any emergency situation comes, how we are going to deal with that situation. But if we try at all, that situation should not occur, what kind of preventive measures we can take, and if at all it occurs, so it should have a minimal impact on our system, maybe a society or maybe some organization. So how do we mitigate with such kind of situation? So if you see this chart here, you will observe 5 different phases. Our focus will be the prevention, and moreover it will be the mitigation of the disaster management, and different measures we should take in order to mitigate the things. So emergency response system, we are aware of, like if some disaster, maybe it is a natural disaster or a man-made disaster, you will be surprised to know the count of man-made disaster nowadays is rising. And we will take one case study only, like we will go into the waste management domain, and you will be surprised to know the figures and the facts that are there presently for our country. So man-made disasters and their management is becoming a crucial task, though the density of that disaster, particularly for the waste management, is not that much seen today, but over the period of time it will be very much difficult to handle this situation. So man-made disasters are creating a lot of problems. Natural disasters, of course, we have the techniques to predict, we have the techniques to detect, and we have the techniques to recover from such situations. So presently we are aware of some solutions which are there with us, not only in India but across different countries. Like we have different kinds of robots, for example snake robots. In case of earthquake, that robot will go inside a particular area and will see to it whether human kind of thing or some living thing is getting identified or not. And such robots are now already into the practice. We also have seen firefighting robots in case of fire, how that firefighting robot is helping the societies. Drone based systems are also there. We have seen a lot of prototypes. In fact, if we see the undergraduate students doing the project, drone based system they're coming up with for the surveillance. If suppose natural disaster occur, and how drone based system is observing it, or surveillance is done, and immediately what kind of action that disaster management system should take, that all is taken care by the drone based system. And of course emergency response system in all the cases, like whether it is a snake robot in case of earthquake, or a firefighting robot, or a drone based surveillance, emergency response system is playing a very important role. That if something is detected, for example in the earthquake, snake robot is detecting a human body, so what kind of action to be taken, how our disaster management system should respond, that all is defined under emergency response system. So these are the present solutions we have with us. Some of them are at the prototype level, some of them are definitely at the professional level, and many organizations are using such solutions. For example, firefighting robots, we see its commercialization, we see its usage in case of the emergency. But like as I said, two categories of disasters we have seen, the natural and the man-made. My focus in this talk will be on the upcoming disaster, I would say, that is the waste. How do we handle the waste, how do we manage it, and how Internet of Things is contributing in the management. So yes, of course waste is a human made disaster, and if you see the facts and figures for the waste management, particularly in our country, approximately 0.7 kg waste is getting generated per person in the urban area. Doesn't matter it is organic, inorganic, overall it is 0.7 per person. Now you imagine the population we have and how much amount of waste is getting generated. So presently we have 62 million tons of the waste, both cyclable and recyclable, that is getting generated. That count is big. And annual growth, if you see that growth rate in the waste, solid waste, that includes everything, organic, inorganic, waste, that growth rate is of 4% per year. Now this tends to increase year by year, and imagine a situation in urban areas after few years we will not have sufficient landfills also to accommodate that waste, to process that waste. So this is a crucial time. We should come into action as the technical individuals. We should come with some solution, right from the waste generation to the waste recycling, and then disposal of the waste. That is not preferable, but if at all it is not possible to recycle or reuse, then we should reach to the disposal of it. So in what way IoT can contribute, and how IoT can save us from this disaster? So there are different IoT systems, but at prototype level they are observed. Like governments are coming with different schemes. We fill up the proposals, we get the sanction, we develop the prototype, but when that project ends, at the end of project we deliver the project, and after that what about the commercialization? What about the use of that particular system we have developed? That has to be used, particularly like we develop, say, smart e-bins. So those e-bins must be seen in different organizations, not as a single product in the institute where it has been developed. So IoT systems for sustainable development, how they are contributing, particularly in the waste management. Like our IoT system shall observe what kind of waste is getting generated, what is the pattern of generation of the waste. Just we take example like in the household activities, for example in the kitchen, what kind of waste every day gets generated. We take up the vegetables from the market, fruits from the market, we bring it to home, we wash them, clean them, put in it to the refrigerator. What about their plastic bags? Are we mixing those bags with the waste or vegetable waste? So improper segregation, then it goes to the dumping yard, it goes to the landfill, and there if segregation happening, it is not useful. So segregation has to happen at appropriate place. In fact, one level up, the waste generation pattern has to be decided, in what way the waste is getting generated, and how IoT system will help in handling that waste generation pattern. So this all everything is taken care in the waste management. When it comes to recycling, our IoT system shall decide, okay, this is XYZ is the waste and it can be recyclable, so it needs to be moved to the particular location geographically, and from there it can be recycled. So we need to bring our system to that level, so that our IoT system will immediately detect the thing and will take it to the recycling. Renewable energy expansion, of course, it will help us for the sustainable development, like more usage of the natural resources, and to some extent more usage of this renewable energy sources will reduce the waste generation. Forest conservation, particularly reforestation, then organic farming, they will contribute in reducing the waste and in achieving the sustainable development in our country. Then education and awareness, of course, education about the waste, how it is getting managed, how it will appear as a disaster in future, and what kind of solutions we will be needing to deal with that situation. This education must be imbibed into every individual. So that kind of awareness, maybe by taking different workshops, or at the school level we can take it to the classroom and we can educate the kids. So these are the things we need for the sustainable development. But what exactly the sustainable development is? Many things are contributing to the sustainable development. See, when we take about we take the example of the food waste in India. If you go to some event, there is a buffet arranged, and you like we take some food in our plate, and if you are not able to finish it, we just put that plate aside, okay, without worrying what will happen with that with the rest of the food, because nobody is charging us the fine. Okay, that is out of freedom we are taking. But in the countries like US or UK, there are strict rules and regulations. Heavy amount of fine will be charged if you waste the food. But if you go to the country like Japan, there it is in their culture not to waste the food right from the childhood. So this is a difference we see across different countries, that what is coming out of freedom, what is coming out of rules and regulations. So there in the countries like US and UK, hardly somebody will dare to waste the food, because that much amount of fine has to be paid. And as a part of culture, when it comes, it is certainly helping for the sustainable development of that country. So it is imbibing to their culture. Those people respect the food, and there is no question of the waste generation. So this is just an example. This is how we can achieve the sustainable development, by deciding to what extent we should take the benefit of the freedom, particularly when we talk about the food. So what are the challenges for this management, and how we can come up with the solution so that this kind of disaster, a man-made disaster, should not spoil the environment on the earth. So rising the waste generation, their levels and their patterns, that is the biggest challenge. Every day, as we have seen the figures, 0.7 kg per person every day. So you imagine the amount of waste after 5 years. An average growth rate per year is 4%. So what amount of waste we will be having after 4 years? So this is the critical challenge, and we have to come up with a solution to deal with this challenge. Then improper waste management. I absolutely agree with this challenge, that everywhere still we do not have the proper waste management, like right from the collection, then segregation, then to the dumping yards, and to recycling and reprocessing. Okay, so even if we take the household activities and the waste getting generated out of those activities, some plastic or some vegetable waste or some paper waste, we do not segregate it properly at our end. So that kind of education and that kind of system shall come, so that the proper segregation happens at the end where waste generation is taking place. The need for adequate infrastructure and resources. This is absolutely true. So you just imagine, or you just recollect, somewhere you must have seen in urban areas that landfills, we find there huge amount of waste collected. Is there a processing unit to process that waste, take the plastic out of it, or take recyclable things out of it and process it properly? So we need the adequate infrastructure for recycling and for the segregation. And environmental pollution and climate change. Yes, that is absolutely true. It is also one of the challenge for the waste management, that environmental conditions also matters, pollution also matters. Even I would say the way we collect the waste, that also matters. The time at which we collect the waste, that also matters. In urban areas, if you see the restaurants at the end of the day, when they close their restaurants, they come up with the huge amount of waste, the food waste or vegetable waste, and it is there near roadside, outside, for overnight it is there. And in the morning, then the municipal corporation vehicle is coming and collecting the waste. So you imagine by that time how much amount of reaction has been taken place with the waste available in that bin. Of course, that most of the waste is the organic waste. Then what reactions has happened, then what it has generated, like how it has contributed to the pollution, and so many things. So that is one of the challenge. In fact, making a small change in the waste management will also help, and will improve the system. Like instead of collecting waste at particular time, why not to collect at the other time where it is not getting decomposed? Okay, by the time you take it to the landfills, or for some recyclable kind of thing, for example biogas, it will be not causing any issue. So these are the things contributing and making it as a challenge. And of course the climate change, like sudden rainfall, or all those things contributes to the waste management, and they become hurdle for the waste management. Just a simple thought you must have seen when if you visited a state called Kerala, there a simple thought that government have put, they have come up with such kind of bins everywhere. So it is very much symbolic. From the shape of the bin itself, you can determine what to put inside this bin. So it is a simple thought on the waste segregation. So we are supposed to put the bottles, and it is very much helpful for the waste collectors. A municipal corporation vehicle will come for particularly for such kind of waste and will take it to particular area for the recycling. So you imagine, instead of segregating like this, if we put everything together, what efforts are needed for the segregation. So this is all the background I wanted to give you, and now we will be diving into the technology part and how those technologies will help us to come up with the smart solutions with IoT and artificial intelligence. So a significant role of artificial intelligence and Internet of Things is there in the waste management. In fact, when IoT comes in the discussion, very first topic for the students specifically comes that waste management they wish to do. So we have plenty of sensors available, like odor sensor you wish to install, or say gas sensor you wish to install in the bin, or say temperature sensor, and you are installing all 3-4 kinds of sensors, and that bin is able to determine whether bin is having particular temperature. If temperature increases, some reactions will happen in the organic waste, and something else will be generated which will cause harm to the environment. Or odor sensor is installed that will detect odor is getting generated, and that is disturbing the environment. So these are simple projects we are aware of, but absolutely they are at the prototype level. We have seen many such projects in our career, but when it comes to the installation into the society, so why not all the societies in urban area are having such smart bins, like other countries are deploying such smart bins, a smart waste management system. So why not we? So it is the high time we should take this topic, or this kind of thing to the societal development as well as the organizational development. Not only like the IT sectors, even the educational institutes, what kind of waste is getting generated, and what kind of facilities we have for segregation of that waste and for disposal or recycling of that waste. So of course we have some AI and IoT technologies for the management of the waste, right from the waste collection, then its transport. Nowadays we have seen the systems that identifies the shortest route or the efficient route that will cover more and more bins for the waste collection, and by following a shortest path, the waste can reach to the dumping yards. So that is about waste transportation. We have some projects with AI and IoT in the area of waste transportation. Then treatment and the waste disposal. So biogas is the example where we are converting it into the different form of energy. Okay, but when it comes to disposal, this is the least preferred option, as I mentioned in the beginning, because nothing can be taken out from this kind of waste. So it has to ultimately go to the landfills, and no kind of energy can be generated out of it. So everywhere AI and IoT is contributing. How do you collect the waste? We need smart collection techniques. We need IoT based smart collection techniques. For transportation also, we have optimistic techniques, and we have the AI based intelligence technique. Then waste treatment as well as for the waste disposal. This is a simple case study. It is called as a smart waste bin. They have named it as a bin E, and this is the smart bin developed by one of the European association, and they have come up with the simple technology, a mix of artificial intelligence and IoT. You will be surprised to see how simply they have they have come up with this form of bin. This is a portable bin. You can move it from one place to another place, and you can see there 4 kinds of segregations this bin is doing. The incoming waste has to be put here. This is a closed flap, but as soon as you take the waste near to this flap, it will get automatically open. So if you remember the COVID period, there we had a lot of issues regarding whether it is okay to touch particular thing or not. So in this case, it is taken care. You don't have to touch a bin. You just take the waste near to this flap. It will get automatically open, and after putting that waste inside, it will detect what kind of waste it is among these 4, whether it is glass, plastic, paper or metal. Once it is detected, there is a conveyor belt. It will take that waste to the appropriate bin, for example paper, and the indication is given here at this its video. If you search for the YouTube video of bin E, you will get a complete video how it works. So it shows the feeling level that the bin of paper bin is full, 70% full, or metal bin is 30% full. So that indication is here. Not only that, the central authority is getting notifications that this particular bin is full and you have to collect the waste out of it. So such kind of bin is suitable for the organizations or educational institutions. We have never thought of the waste we are generating in our working hours, like mostly the paper or the plastic kind of material, or sometimes it is glass or metal. Such kind of waste we are generating. Hardly the organic waste is involved. So the organizations, the educational institutes can deploy such kind of bin, and there can be appropriate segregation. So main purpose of this bin E is to segregate the waste properly, and the waste collector will come and will take it to the recycling or for the disposal if required. So this was the simplest case study, and now we will see the technology part of it. So how AI is getting involved. So as soon as we move to this flap, there is the object detection technique. Like some object has come. Once we put that object, it is detected what that object is, and then it is classified among 4. So there comes some machine learning algorithms. Then this automatic operation of flap that IoT is taking care. Then automatic waste sorting is taking place. Of course, the detection of object is helping for the classification. Then compression of plastic and paper is taking place. You can imagine if we put 10 bottles without compression here, the bin will get full immediately. But this bin E is taking care of it. Before putting the plastic bottle inside this bin, it is getting compressed. So you can imagine the amount of space it is occupying. Same for the paper also. Before putting it into the bin, it is getting compressed. Then fill level control and alerts are there to the central authorities. Accordingly, bin can be made empty. It can be the waste can be collected and bin can be made empty. Then apps for the statistics and reports, assuming that municipal corporation is observing such bins established into different organizations. So municipal corporation is coming to know what is the statistics, that which bin is full, that, or they can in fact predict the amount of waste that will get generated in upcoming days or a month or so, because the waste generation pattern can be learned from every organization on the basis of the history, what kind of waste they have generated, how much waste they have generated per month or per week. So accordingly, the planning can be made. So these were the features for bin E. Another case study which is very popular, sensor-based monitoring systems we have, like you must have seen such prototype also, that bin with some set of sensors like a temperature sensor or infrared sensor or gas sensor or a humidity sensor. And as soon as the waste come into the bin, say the fill level you wish to detect, so there will be a system in the bin that will detect how much bin is full, and accordingly the notification can be given by the central system to the controlling officer, and accordingly the waste can be collected. So such sensor based waste monitoring systems are there, but practically these are not in use, or we can say in simple, they are not in practice. So once they are in practice, definitely it will help in managing the waste in the proper way. Now, models to predict the waste generation, like in order to determine what is the waste generation pattern in particular organization. Let us not talk about the society, because I suppose the waste that is coming out from residential societies, the solid waste, that waste is very difficult to segregate. Even though the municipal corporations are running campaigns, they are making it mandatory to segregate the waste at home itself. They are asking us to put 2 bins, green for something, red for something, but still there is a big challenge for the waste segregation. When the waste collector comes, how that waste collector is handling 2 different types of waste. So we need to have set of models, the artificial intelligent models. Those models will predict the waste generation, in fact the waste generation pattern, in fact the amount of waste every day this organization particularly is generating. So what this model shall do, this model shall learn the pattern of waste generation, like my organization every week, what is the type of waste is getting generated more every week. So accordingly that model will learn ki from this organization paper waste is coming more. So accordingly the recycling or the collection can be planned, like how many cycles of collections are needed and where it has to be taken for the recycling. Then sensors to track the amount of waste generated. Yes, we as a part of IoT system, we need to install set of sensors to track the amount of waste generated. That is what we call it as a bin fullness level, to what level it is full, and once it reaches to some level, maybe 70% or 80%, what action has to be taken. So that is again essential objective of this model. Then identifying the sources of the waste, from where it is coming, then measuring the effectiveness of the waste management strategies in specific area. Like as I gave example of the vegetable waste or the entire organic waste coming out of the restaurant every night. So presently our waste collection system or the waste management system there, the waste collector is coming in the morning, maybe around 8 a.m. By that time the food or the vegetable waste gets degraded. It creates a lot of smell. You cannot even pass by through that place. So is it effective method? So what changes we shall make so that the waste collection will be effective? Then preventing the bin overflow, that is also important objective to be achieved when we develop a model, that how our AI system with IoT will help us to predict, to prevent the bin overflow. So we have the set of sensors that will allow us to achieve this particular objective. Now we have seen in general, we started from the disaster. Our focus was one particular disaster. It is upcoming disaster, man-made, and how it is presently handled. What are different steps in it? Some of the case studies also we have seen. Now, where is the exact role of artificial intelligence and the Internet of Things? So when we talk about the predictive models, that my waste management system shall predict ki this much amount of waste is expected in upcoming month from XYZ organization. So there comes the role of AI. If my waste management system is telling ki and this is the present temperature inside the bin, you have the organic waste in this bin, so with this temperature what it will cause and how it will contribute, or how it will create a harm to the environment, or how it will contribute to the pollution. So IoT kind of thing is coming in picture. So we have few machine learning and computer vision techniques for image recognition, specifically for the waste classification. As bin E, we have seen 4-class classifier is mentioned there. We know those 4 classes, and this machine learning model need to classify among these 4 classes. Then deep learning models for automated sorting. As soon as the object comes in front of the bin, that bin E is determining what object it is, and the deep learning model is automatically sorting it. Not only CNN, but there are models like AlexNet is there, or different deep learning models that can be trained and used for the AI part of waste management. Then robotics and automation, particularly these elements we need at the landfills for the waste segregation, because if you see the landfills, you will find combination of everything. You just pass by some landfill, and you will get to know it is mix of everything. We have plastic, degradable, non-degradable, everything. So why not to have a robotic arm? That robotic arm will take out all the plastic from that landfill and will put it somewhere, and then that plastic can be taken ahead for the recycling. So robotic and automation is the part where robotic arms will play important role in the waste segregation, picking up the things and sorting the waste. And autonomous garbage collection vehicles, like as soon as the centralized system is indicating the bin is full at this particular place, so our system, waste management system, shall automatically send a vehicle to collect that garbage, irrespective of any specific instruction. So today only I was discussing with one of the professor from Don Bosco College, Mumbai, Kurla region. So that professor mentioned a very simple idea to manage the waste. Like, we are very much familiar to the Google Maps, and when we travel and we put on the Google Map from some source to some destination, and if we see something has happened at particular place, and if XYZ person is ahead of us, and he finds some road work is going on, so that person puts a notification there. We get to see 2 persons reported, 3 persons reported, 15 persons reported. So why not to use this Google API for indicating the bins they are full. Like, we should get on the bins onto the map, and at this particular location bin is there, and the fullness of that bin or the status of that bin. So that will also surely help to some extent to manage the waste. So this was very simple and interesting idea. In fact, we can ask our students to do it and demonstrate it, and we never know that how it will help in management of the waste. So there are different such technologies used for the management. Some big data and predictive analytic technologies, like most popular models, like we have regression models, we have classification models for predicting the waste generation patterns. If some organization waste generation pattern is generating paper waste more, so that model will learn and it will predict this much amount of overall waste you are generating per year or per month. Then optimization technique, it is helpful when it comes to the best route selection for the waste collector. When that municipal corporation vehicle comes for the waste collection, which is the best route that vehicle should take, by covering maximum number of bins from which the waste to be collected. So here optimization algorithms comes in picture. Like we have most popular genetic algorithm, we have graph based optimization that can help us to come up with the best route for the waste collection. So of course it is based on the historical data, and day by day, suppose bins, more and more bins are getting installed. Accordingly, our optimization algorithm shall give answer which route has to be taken. So there are number of techniques. We have listed few here. There are different artificial neural network models. There are image processing, computer vision techniques to recognize the objects. There are machine learning techniques for the classification. The question is what care we should take while choosing when it is a model and when it is a data. So model is not enough. So when we say artificial intelligent model or a machine learning model, without data, that model cannot do anything. We have to feed some data. We have to train it for a particular pattern. Like it is just like a human brain or human nervous system. Like we learn something, we repeat it, we accumulate the experience, and based on that experience, we give the output. Like just the childhood example, that our mom taught us this is apple, this is an orange, so we learned the classification. We were not knowing that is a classification. So that learning was repeated twice, thrice over a period of month. Until now we remember that classification and we are able to classify it appropriately. Same thing our machine learning models are doing. So more appropriately we train and more experience that model accumulates, it will give the classification accurately. But that can be done with the help of data only. We have to support it with the genuine data. Nowadays adversarial attacks also we are experiencing on the AI and IoT kind of thing, that sensors data getting hacked, or the AI model data getting hacked, and it has become worse with the generative AI kind of thing. If somebody is creating a synthetic data with the intention that adversarial attack should happen on this particular machine learning model, so that is the worst thing. This should not happen. So we must take a care ki what model to be chosen and what kind of data should be chosen. So correct tool means correct model. If you have a correct model and you have a correct data while training that model, the correct decision that model will give. And very simple rule, if we have a correct tool or a correct model with us and we have a wrong data, like we have a model for say we wish to predict the rainfall, and we are training it with some other data that is absolutely not related to the rainfall or the climate, then obviously incorrect decision the model will give. If we have a wrong tool, doesn't matter, you have correct data, you have wrong data, obviously our decision will be wrong. So we must take a care ki we should have a correct model with us and we should have a correct data. Now if we give garbage in, obviously it will be a garbage out from that model. It is very simple rule. It is not the astrological parrot. That parrot, if you remember, the astrological parrot picks up the chit randomly, and once you open up that chit, something is written inside it and that becomes your horoscope. It is not like that. If you give garbage kind of thing as input to the model, output will be garbage. So we are responsible to choose the correct model and correct set of data, so that result of the model will be correct or the decision will be correct. Now next question arises, when to use what? So we have seen some case studies. Now we need to deal with this form of upcoming disaster, and we need to manage the waste properly. And we know these are AI techniques, these are IoT kind of things, these are machine learning techniques. But question comes is when to use what? So when we talk about regression, some basic form of machine learning models like regression, when to use regression, very simple. When our output variable is real or continuous value, we shall go for the regression. When our output variable is not a real or a continuous value, it is categorical, discrete form, then we should go for the classification. Suppose I want to predict the temperature of the patient for upcoming days. I am expecting particular temperature, means value. So I shall go for the regression technique. Quantitative kind of thing you can expect under regression. Qualitative kind of thing here as a classification. So where you categorize. There are standard and very simple form of regression techniques. You must be knowing the simple linear regression and how it will contribute to the waste management or to some technique or some mitigation technique for the disaster management, we shall see. So this is a simple linear regression representation. The equation of line, we call it as that slope and intercept, how they decide the value of the output variable if the value of input variable x is given. So we call x as the independent variable. Say x is the in case of e-bin, or in case of the waste management, suppose here we supply the value of say some reading taken from the sensor, what kind of output we can predict, we can determine, that can be modeled here. So x is our independent variable, you know its value, and y you are computing. If you represent it, the relationship between dependent and independent kind of thing, it will appear as a linear nature. And these points indicated here, they are our data points, they are lying close to the linear regression, and when we see this particular point, this point do not fall close to the linear relationship. How exactly to model this linear regression mathematically? With different set of tools, we are able to do it easily, but how it take place, how we get the slope, we have two-dimensional space with us, and you can see one variable like dependent variable at y-axis, independent variable at x-axis. We simply get the difference of y coordinates divided by difference of x coordinates, that gives us the slope. And intercept is computed by the difference, along with the help of slope we get the intercept. So this is simply modeling a linear regression. Just for example, these are the values for the sales but this is just an example. We'll relate it to the waste management. At farmer's location, for the sale of the vegetable is suppose 4 units, at village it is 12 units, at town level it is say 28, at city level 52, and at metro cities it is 80. So why not to predict the sale of the vegetables in the units at say state level, okay, or urban areas? So we can simply model a linear regression for this. We can identify which is dependent variable, which is independent variable, and we can compute slope as well as intercept and come up with the value for a particular location. So there are different examples you can model for linear regression. Next term comes in regression category, logistic regression, when we are not concerned about the values, but we are concerned about their probability, like yes or no kind of thing, or true or false kind of thing. There exactly the logistic regression matters. So for example, in the waste management, that central authority need to decide whether the waste collector should reach to this particular bin, yes or no. So that kind of decision can be given by logistic regression. How do we model logistic regression? We have again the response variable, the dependent and independent variable, and the coefficients, and this way we model the logistic regression. Of course, it is a multiple variable logistic regression. Same way for the linear regression, you can model a simple linear regression as well as multiple linear regression. This is how we have covered when to use the regression techniques. Now, when to go for the classification? We should go for the classification when we need to do the categorization, or we need some discrete representation. So what exactly the classifier shall do? For example, one classification we have seen in that European Association bin, it is a 4-class classifier. If we see to the technology part of it, it is a 4-class classifier machine learning model. So what that classifier is doing, it is classifying among anyone, classifying the object among 4. So what it has learned, what features it has learned, what features it has learned for the paper kind of waste, or what features it has learned for plastic kind of thing, or a glass kind of thing, or a metal. So that learning is what we are going to understand with this category. So class label will be given out of this. We will see particular classifier, and through which we will evaluate how classifier is actually working. Sometimes those classes are also called as the categories. For example, this is a classifier. We give some input attributes, or you can call them as features. Like for the waste collector, if this is our classifier and the features are the bin is fullness of the bin, that percentage is there, or the sensor is working, it is giving some reading, or temperature sensor is indicating high temperature, and so on and so forth. So based on these features, what classifier shall decide? Classifier shall decide whether I should go to collect a waste or not, yes or no kind of thing. So when you say yes, no, this becomes a two-class classifier, and it's very easy to implement a two-class classifier. Nowadays we have ready-made models, but if you do it manually with artificial neural network, a two-class classifier is very easy to develop with unipolar or bipolar binary kind of activation function. So in a nutshell, or a black box kind of thing, classifier will take some features as the input, and based on those features it will categorize the thing. So they can be called as features or attributes, or yeah. So what is the general approach in the classification? It's a two-step process. First, that classifier will get learned, and once it completes the learning, it will classify. So very similar to the human kind of learning. We learn it first, like we learn that classification of apple and orange in the childhood, right? Still we remember, but we learn the Bicot normal form in database management system some years back. Okay, but at this moment, if we try to solve it, or if we try to apply Bicot normal form on particular relational database, it becomes difficult for us, because we learned that in the past, but what about the experience we collected or we accumulated based on that learning? So learning is not enough. The experience with that learning matters. More is the experience, more accurate will be the classification. So in two steps, it will learn first and then classify. Classify means it will predict the category. So in learning, what exactly the classifier is doing, we provide set of tuples, the training tuples. We call it as a training data set. We have some training pairs, we have some testing pairs, that division and all. Again, it is a different story, different part of the artificial intelligence thing. So we train the model, we use some training tuples, and once the training is accomplished, we go for the classification. So for training, we use the training tuples. Each tuple or each data sample is indicating some set of features, or we can call them as attributes. So those attributes are actually responsible for the classification. So we will see here the general approach of the classification. Then we will see how it can be used in the waste segregation. So suppose our classifier is now presently learning the classes, what classes, what is the training sample, and what attributes, what are the features. So we are basically composing this. This is our output function y, or you can call it as a mapping function. How it is mapped, this function we are performing on the given input tuple x. It has number of attributes. For example, this is our data set. We have some attributes, or the features, like age is the feature, income is the feature, or credit rating is the feature, and the last column is indicating the class label, yes or no kind of thing. So you can observe here, this classifier have only two classes associated with, one is yes, another is no, and we have this as a label data set. This is very popular example. And what this classifier has to do, it has to learn based on the features whether particular customer will buy a computer or not. Yes means will buy a computer, no means that customer will not buy a computer. So this learning has to be given to the classifier. So we have some training data, and from that training data or classification algorithm, yet we have not decided which classification algorithm we will be going for, maybe decision tree or naive Bayesian, or among anyone among the list. So what that classification algorithm will do, classification algorithm will form the decision rules, or say if it is a decision tree algorithm, so if I check if the age of the person is youth and income is high, that customer is not a student and credit rating is fair, in that case the customer will not buy a computer. So in which case the customer will buy a computer? If this is the age, this is the income range, and this is the credit rating excellent, in that case the customer will buy a computer. So classification rules are coming out of the learning. And once the classification rules are ready, then new data patterns can be given for the prediction of the class for the tuple. So what this model is doing, we will first train the model, and then we will see to what level it has been trained by computing the accuracy. Accuracy again is very simple element, like if we train the model for say 1,000 tuples, and out of that 8,000 are getting classified correctly, we say that our classification accuracy is 80%. So that is exactly the percentage of the test set of tuples that are correctly classified. Okay, this is the test data, not the training data. 1,000 we are giving for the test data, and 800 are getting correctly classified. So let us have a look at most important component in AI techniques, a decision tree classifier, and how decision tree classifier helps us in developing the solutions like BinE. Okay, that 4-class classifier, how it has come. So this is a simple form of a decision tree manually plotted here. So at the root node, we are checking what is the age. If it is youth, then we check whether student. If no, then the leaf nodes indicating the class labels, whether the customer will buy a computer or not. And but if age is the middle age, whatever is the credit rating, whether that particular person is student or not, the customer will definitely buy a computer. So you can see multiple decision rules here out of this tree. Now the question comes that why out of all the features we had their age as a feature, student as a feature, or credit rating as a feature, right? So out of all these features, why only age has appeared at the root level? Why not student has appeared here, or why not the credit rating has appeared here? And that is what the important thing about the decision tree, why age is sitting at the root node. So we need to find out this. Okay, so what is our goal while designing decision tree? Like we simply practically we simply give our training patterns to the model, we train it, and then we test it. We get the accuracy, and we say that yes, our model is trained and it is doing accurate classification. But how exactly it is happening? So we need to create that decision tree, and we need to see to it ki what node or what feature has to be placed at what particular position. So in order to do that, how we decided ki this particular feature is coming at the top of the decision tree, and this particular feature is coming in the middle, that we will achieve by attribute selection measures. We have number of features, we have number of attributes. Out of that, which is the best suitable attribute that will go to the root level, or which are the other attributes that will go to the second level, third level, and so on. Tree pruning, we will see at the end how we will handle the noise, how we will handle the outliers in the training data. But we want to improve the classification accuracy, and your classification accuracy will be good if you select the attributes appropriately. So let us see what are those attribute selection measures. We have number of measures. We will not go through all. Like I need to decide which attribute will go to the root level. So the measures like we have entropy, we have Gini index, we have gain ratio. In fact, the information gain we are familiar with. We have studied this information theory and coding. So information gain is again the most popular attribute selection measure that will tell us ki how much information is available with this particular attribute that can give us the correct classification. For example, I have the feature age as a feature. So if I am able to compute the information gain for this particular feature, And if I find it to some level that can indicate that this is the best attribute for the partitioning of my data set, in that case I need to go for the information gain of this attribute or this feature, as well as the credit rating feature and all available features of my data set. So why we need attribute selection measures in decision tree particularly? These attribute selection measures will help us in deciding which is the best attribute or which is the best feature to partition my database data set, so that my classification will be correct. So we have number of features, number of attributes. Out of that we have to select one at a time. So that is why we are going for these measures. Number of measures are there. We will go for information gain as an attribute selection measure. So if we have n number of attributes or n number of features, then which attribute to be located at the root, we are going to decide now. So we will go for the information gain form of attribute selection measure. So what exactly information gain is? Let us compute it quickly. This information gain in the information theory and coding, if you see its interval, it is 0 to 1, and it tells ki how much information is hidden inside this attribute or inside this feature that is sufficient to partition my training data set. So it is computed on basis of two elements. First, we compute the expected amount of information needed to classify a tuple in your data set, and then expected amount of information needed to classify a tuple in data set on basis of particular attribute. So first thing we are doing with all the attributes, that is this one, we have here two classes and all the attributes are taken care in order to compute the expected amount of information. And second component, we are extracting on the basis of particular attribute, how much information is needed to classify a tuple on basis of age attribute or on basis of say student or credit rating attribute. So it is simply the probability, non-zero probability for any arbitrary tuple in the data set that belongs to particular class. Now in our case we have only two classes, either yes or no. So this summation will have only two terms, and then we compute this information, expected amount of information that will classify a tuple in a data set. Now once we get that, we also call it as a entropy. Then we move to the computation of the information needed for classification on basis of particular attribute. So how it looks like, for example, this is the information expected for classification of particular tuple in data set on basis of attribute A. So here we take care of that particular attribute, and it is the weight of jth partition, like how that partitioning or the probability of that partition is occurring. I will show you. For example, this is the expected amount of information, as we have only two classes, if you remember, yes and no, and in our data set we had only 14 tuples, for example this. So we have only 14 training tuples here. Out of 14, if we count that 5 belongs to 1 2 3 4 5 belongs to the no class, and remaining 9 tuples belong to yes class. So our expected amount of information needed for the classification in training data set D, total are 14. Out of that, 9 are yes class and 5 are belonging to the no class. So using that formula we discussed earlier, the information coming out to be 0.94, but this is not the information gain. This is only the expected amount of information needed for the classification of any arbitrary tuple. But what about the expected amount of information required for every attribute? Like we have 4 attributes. So for age attribute, if we see, out of yes, total yes tuple were 9. So if age range you take, it is youth, middle age and senior. So among 9, 2 are youth, 4 are middle age and 3 are senior. So total is 9. And in no category, 3 youth, 0 middle and 2 senior. So this is what segregation or partitioning we have done on the basis of particular attribute. Earlier, this one is not a partitioning. This is on the basis of entire tuple. But when it comes to the particular attribute, we compute the expected information required for each attribute, and let us compute it for only age attribute as per formula we have prescribed earlier. So out of 5, 2 are here you can see 2 are senior and 3 are youth. But here out of for age attribute, out of 4, all 4 are middle age, and for senior, if you see for senior, it is out of 5, senior is total 5. Out of 5, 3 are belonging to the yes category and 2 are belonging to the no category. So this is coming out to be something 0.69, but yet we have not reached to the information gain. So we are interested in computing the information gain for particular attribute. Say age is that attribute. So it is simply the difference between the total expected information we computed earlier based on all the tuples, that was 0.94, minus the amount of information needed for the classification on particular attribute, say age attribute. So it has come in the previous year, it is 0.69. So difference if you take, it becomes 0.24, and this is called as the gain. In fact, we call it as the information gain for the age attribute. So in simple information gain, we have defined it as a difference between the amount of information needed for the classification based on all the attributes minus the amount of information needed for the classification on particular by categorizing in the particular attribute. For example, age we categorize middle age, senior, and young. So that way it has given us the value. For example, this 0.24, and in the same way we compute the information gain for income, we compute the information gain for student attribute, we compute the information gain for credit rating. As we had 4 features, we got 4 values for information gain. And the information theory and coding states that wherever is the highest value of information gain, that is the best suitable attribute for the partitioning. So we can observe here 0.24 is the highest value of information gain for the age attribute. So age is that feature which is having highest information gain, highest amount of information hidden inside it, that can give us the best classification. That is why very first partitioning in our data set shall come from the age attribute, and that is the reason why the age attribute is placed at the root level. And we repeat the same process for the remaining features or remaining attributes, and that is how the tree will grow and the partitioning can be done. So next question might be why we are doing the partitioning, because that is helping us to construct the decision tree, and once we construct the decision tree, we can come with the decision rules. And once you are done with the decision rules, it means your model is trained. So practically we have trained several models for several data sets, like whether it is waste management, any kind of disaster or mitigation technique or mitigation measures. As a part of mini projects, major projects, we have trained so many models. But wherever we have used a classifier, what actually is happening with the classifier is this, that model is first partitioning our data set on the basis of highest amount of information gain, and that partitioning continues till the entire tree is formed, and then our model comes out with the decision rules. So this is what the resultant decision tree is, and that is why the student and credit rating attributes are placed over here. So not only decision tree, we have few more algorithms in AI category that can give us the classification, but we need to decide when to use what, as we have discussed. Like number of classes also matters. Probability, wherever the chances of probabilities are there, we need to see what is suitable there, where the decision tree is suitable, or the naive Bayesian kind of thing is suitable. Now let us relate it with the waste management kind of thing. Like we have a BIN-E in front of us, and it is acting as a 4-class classifier. It is equipped with IoT and electronic kind of thing, and it is now a commercial product in the cities of Europe. So how we can have such kind of setup for us? So technology part, we know how to do the classification, how to install the sensors, how to collect the data from the sensors. In fact, some of us might have done the project with the undergraduate students at the prototype level. So what next we should do so that it can be delivered to the society? So we can approach to the government agencies for the financial support in order to take it to the product level and then distribute it in the society. Not only that, if you are there with the urban areas, you can contact municipal corporations. Like we remember in past, one of our student team went to NMMC, that is Navi Mumbai Municipal Corporation, and that Navi Mumbai Municipal Corporation gave some amount of fund to develop a snake robot that will help in the disaster management and will detect the human body in case of the earthquake scenario was given to that group, and student came up with that prototype. Okay, after that, then deployment of it matters, and somehow we should relate it with the incubation center, so that companies will come into picture, stakeholders, different stakeholders will come into picture, and then it can be taken to the product level, and then it can be deployed into society. Not only that, if you take a smart bin kind of thing, if presently if you have a smart bin at your place with your student, demonstrate it to municipal corporation. You can go there, visit there, demonstrate them how it can help. You can fetch fund from the municipal corporation and ensure them that how many smart bins you can develop, and you can install it at different geographical locations. So it is as the technical individuals, or I believe our role is not only to come up with only the technology part, developing something, rather deployment matters a lot, because once something is deployed, then only that solution will be helpful to the society or to the organizations. Anyway, so research angle of this IoT and AI ML and disaster management is again completely different. So we have been into a lot of technical things of AI and ML models. Further, there are other models as well, but I am skipping those models as of now. There are some proposed problem statements, not only related to the disaster management. In fact, taking into consideration the sustainable development in our country, what matters for all of us. So human services like healthcare is the biggest domain, I would say, where IoT and AI ML kind of thing are playing important roles. Transportation, even in the not only in the sustainable development, in case of disaster also transportation matters a lot. Smart transportation we should have, so that emergency response system can be activated as early as possible. Government agencies, where AI and IoT playing crucial role. Environment, there are a lot of environmental projects coming into picture, taking care of pollution, measuring the elements in the air, and indicating something like I'm happy to share that at our institute we have deployed the weather station. That weather station, it captures the readings, that what is the amount of humidity, CO2, oxygen, all that, so many parameters it captures. And the data set, every second it is capturing. We have the data set, and some analysis students are doing, and students are predicting upcoming environmental conditions for the vicinity, approximately 16 kilometers nearby our organization. Agricultural, social media, and so on. This is the limited list, but these are the proposed domains, I would say, there we can contribute, and all these are essential elements in the sustainable development of our country. So I think I should stop here. I try to relate with the sustainable development because I think it is very important for us, and how we can contribute in that development. Like we have a lot of potential because we have student strength with us. They do different kinds of projects. If at least one project, if in our lifetime is coming, and if it is really helpful to the society, I believe whatever job we are doing, that will be really justified, and that will definitely help the society. So I will not move to the next slides. This is what I would like to stop here. Yeah, any questions? Hello, am I audible?
Yes, ma'am, you're audible.
Yeah.
Participants, if any questions from your side? Ma'am, I would like to say, we at our place have this project of smart dustbin, which was simply being used for sorting of dry and damp waste. But and it was like being used through the IoT sensors.
Mm-hmm.
But now listening to your presentation, I got new ideas regarding how it can be innovated further.
Okay,
And
so I suppose the presentation, I mean, really,
really, it
if
was
you
a
can
really
take the
helpful
project
one.
ahead, you can talk to municipal corporation,
Right.
demonstrate them, and give them idea how it can help
Right.
keeping your city clean. That will
Definitely.
really, yeah.
We were already in process of going with the this thing, municipal corporation, but
Excellent.
the various other methods you have given us right
Yeah.
now, which is being
But
demonstrated through your PPT.
one suggestion I will give you: you first file
Okay.
the patent and then take it to the public.
Okay.
Yeah, you
Sure,
first
ma'am,
let me
definitely.
see to it that what innovation you have apart from other smart
Okay.
devices. Yeah, and then you can take it.
Ma'am, surely I'll contact you personally regarding this.
Yeah, anytime.
Sure. Thank you so much. Yes, participants, any kind of questions?
I think it's dinner time for all.
All right, it's already 9 p.m.
Okay.
But we had lovely sessions today.
Thank
So
you.
thank you so much, ma'am. It was pleasure listening you. You have very briefly explained how waste management can be done, and that way, how it can be used, or IoT can be used for its proper for the disaster management part.
Yeah,
We'll
my
definitely-
concern was
Right.
waste has to be considered as a disaster now. Otherwise,
Definitely, ma'am.
Yeah.
So yes, please proceed. Ma'am, please continue.
Yeah. So if there are no questions, we can, quit the session. If any participant wish to connect, I have shared my presentation with sir, the coordinator, sir, and you can pass it on to the participants.
Definitely,
My contact
ma'am.
details are there on the first slide. And it was nice opportunity. In fact, I belong to that area. We are our native place is there near Nagpur, Wardha, and it is
Okay.
nice to connect to the organizers and the participants. So thank you, everyone. Convey my regards to Tirupati sir. And
Definitely, ma'am. Definitely. Thank you so much. It was very informative.
It was our pleasure, madam. Whenever you will be here, definitely visit our college.
No, in fact, we need such opportunities to connect with you people. Otherwise, see that
Definitely.
maintaining that connect is very important.
Yes, very sure.
You're
Thank you.
most welcome. Whenever you are here, just let us know, ma'am.
Sure. Okay. Thank you, ma'am. Thank you.
Thank you. So good night, everyone.
Yeah.
So we'll meet tomorrow again at 6 p.m. So thank you. Thank you one and all. Bye-bye.
Bye.
Bye-bye.